going to be talking about parabolas now. And parabolas, there's actually a lot of information here and a lot of important information. We're going to really center on three sections in chapter 4, 4.1, 4.2, and 4.9. But let's start talking just about what is a parabola and what does a parabola look like. So we're going to start talking about parabolas. I want a little thicker line here. All right, and so let's just talk about a general parabola. A parabola kind of looks like this here. That's the general look of a parabola. All right, so let's talk about what are some important parts of parabolas. One of the most important parts of a parabola is the lowest point that it gets to, which is called, I'm going to get a different color here. Sorry, it's called the vertex. All right, so the vertex is just the point that's the lowest or the highest, and sometimes will be at the highest. So if my point was down here further, it would be 1, 2, 3, 4. So this point would be at 0, -4. That's the vertex, okay? In addition to the vertex, a really important point or a really important value in a parabola is called the axis of symmetry. So this is the axis of symmetry, which means on either side of that line, it's symmetrical. The curve should curve up the exact same way on the right side of that axis of symmetry as the left side. Other areas that are fairly important is where we have and where we cross the x-axis, all right? So these are called the x-intercepts. Sorry, x-intercepts. And there's usually two of them. Sometimes there's none. We'll talk about that. So sometimes you don't even cross the x-intercept, but a lot of times we do, and it is helpful to know where those x-intercepts are. Okay, so where is it going to cross the x-axis? The x-intercepts are values where x here would equal 1, 2, 3, 4, 4, 1, 2, 3, and this one x would equal -4. Oh, didn't come out right, sorry. That's a -4. All right. So our x-intercepts are just showing, that where it crosses the x-axis. Let's look at another example here of a parabola. Let me get another thicker line here. In this parabola, I'm going to kind of just more freehand it. There we have another parabola. So parabolas can be a lot of different shapes. They can be really thin. They can go out flatter, thicker. But let's just talk about what were some of our important parts here. First of all, this important part was our vertex. So even if it goes upside down, all right, it's considered the vertex. The next thing I want to talk about is this axis of symmetry. Just to remind you that this is called the axis of symmetry. All right, and other important things would be our y-intercepts. So it really is important to know, kind of what we're talking about when we're talking about a parabola. So I might have a parabola. I talked a little bit about this I said, well, you know what? We might have a parabola that doesn't have an axis, or it has a vertex. All parabolas definitely will have a vertex, and sometimes they kind of get in a goofy place, but sometimes it never crosses our x-axis, and so there is no x-intercepts at all there. The one thing we'll look at a lot is we'll be looking at y-intercepts a lot, and sometimes that y-intercept will just help us to know where things cross. So if we didn't have an x-intercept, it's kind of a goofy looking parabola, but having the y-intercept would be really helpful. Okay, so we look and we start this chapter a little bit. You'll see a few problems on just, graphing and how do you graph, but it's going to be a lot more about the equations. And the equations are given to us in three different forms. First is called intercept form. Then we have standard form and vertex form. Let's talk about intercept form. In intercept form, a big part is how do we find the axis of symmetry? Axis of symmetry is given as always, x will equal the p plus the q divided by 2. Well, let me talk about why that is. when you have your intercept form, and it kind of looks like this, you can kind of see this is an example of an equation given to us in intercept form. It's a nice problem in that you can look right at it and tell me where are the intercepts. So the x-intercepts, I'm going to just say x-intercepts like this, are at x equal p and at x equal q. All right. Now that x-intercept is helpful because if you know that where that crosses the two axes, you can say, okay, well the axis of symmetry has to be halfway between it, okay? Because wherever it crosses, like here's our x-axis, wherever it crosses, the axis of symmetry has to be right halfway between the two. And so that's why the equation for finding our axis of symmetry right here is really the equation for finding the halfway mark between my two um, intercepts, x-intercepts. Once you have the axis of symmetry, then you can find the vertex. All right, the vertex is always on the axis of symmetry. Find vertex by finding the y. All right, so your axis of symmetry is you're going to get an x here, and you have to find this. All right, find or calculate it. I'll give you an example here in a minute. We're going to have to calculate that. Let's go on and we'll talk about the standard form. In the standard form, this is probably the most popular. We're going to have that axis of symmetry is always the negative b over 2a. Negative b means the coefficient of our x value, not our x squared value. There's always going to be an x squared value, an x value, and a constant. So it's the coefficient of the x value divided by 2 times the coefficient of the x squared value. Okay, so that'll always be my axis of symmetry. There. Again, that x is kind of part of, we're going to be able to calculate the y that falls under there, okay? So for this one, this would be my b, and this would be my a, and we're going to show you how to example how to solve that here in a minute. The last one is vertex form. In vertex form, you can look at it immediately and say, oh, I can just look at it and tell what the vertex is. The vertex is going to be at PQ. All right, in other words, this is my x value for my vertex, this is my y value for my vertex. Now, the vertex x here always matches the axis of symmetry x, okay? And so that one just kind of goes really quick in that you can find the axis of symmetry and the vertex fairly quickly, okay? So I gotta go back here just a minute here. All right, so what we have here is we have intercept form. In intercept form, you should be able to look at it and say, oh, I know exactly where my x-intercepts are going to be. My x-intercepts here are going to be what makes my first grouping a 0 and what makes my second grouping a 0. And what makes my first grouping a 0, x minus 4 equals 0, that means x must equal a 4. If x minus 2 equals 0 in my second grouping, that means x equals a positive 2. So let's talk about how does that impact our graphing. Let's graph this one. All right, so let's graph those 2 points. X equals 4, 1, 2, 3, 4. Here is where it's going to cross the x-axis, right here. All right, and then let's see about where it's going to cross in the other one. The other one was x equal 2, and so here is x equal 2. So they're actually fairly close together. All right. So we know it's going to cross the x-axis. We have to decide where does my line of symmetry go? And if you remember, your line of symmetry is a vertical line. Well, the line of symmetry always goes exactly halfway between them. All right, well, halfway between these, we can calculate. I'll show you how to calculate it. If I was going to calculate my axis of symmetry, and here I kind of shows you how, it says we can just take my P plus my Q and divide it by 2. 6 divided by 2 here is at 3. So in other words, at x equals 3. That's this line here. It's x equals 3. We could visually have seen it too. Well, the axis of symmetry is where the exact same thing happens on the right side of that line as the left side, and kind of our curve, and it's kind of like a smile, all right, or a frown, depending on how our parabola goes. So we have to find the vertex, because that's going to show us our highest or our lowest point. The good news is these always match. So our axis of symmetry being x equals 3, that means the vertex, the first value is 3. It's always on the axis of symmetry. We just have to figure out the second value. So what we have to do is we have to go back to our original equation. This is what they originally gave me, x minus 4 and x minus 2. And I say, well, what is y? What is my y here when x is indeed 3? 3 minus 4 and 3 minus 2. Well, y would equal a negative 1 times a positive 1, which would be a negative 1. So y equals a negative 1 when x equals 3. So the answer here is this is a negative 1. So the point that I need right here is this 3, negative 1. So here is my, I'm going to move it just a little bit there. There is my lowest point for my axis of symmetry. So to graph this then, I just need to, oh geez, I'm off a little bit. Sorry guys. All right, I'm going to move this down a little here. There we go. That's what I need. Let's get that out of there. Okay. Okay, so there is my nice parabola. And we're doing sketches here. Don't worry about your parabolas being just perfect, all right? So we're going to kind of catch on to just how these axes of symmetry. Okay, so now we have an equation. We have negative 2x squared minus 8x plus 3. And first thing we have to do here, this isn't one where we can just look at it and say, oh, we can figure out the intercepts like we could before. So now we're going to first use our equation and say, in this case, in standard form, the axis of symmetry is at the negative of our b term, and it's a negative of a negative 8, over 2 times our a term, 2 times a negative 2. Okay, so the negative of a negative 8 is positive 8, and we have over a negative 2. So our axis of symmetry is at a negative 2. So if you remember, our axis of symmetry is this straight line, and we have to put it at x equals negative 2. So x equals negative 2, here's x equals 0, x equals negative 1, x equals negative 2. That's x equals negative 2. So that helps, all right? The other thing helps is we're going to have to figure out what's our highest point or our lowest point, depending on how this parabola goes. So I'm going to figure out where my vertex is. So my next thing is, what is my vertex? And the good news, I already know that in the vertex has to be somewhere along this purple dashed line. And so my vertex x is going to be at negative 2. So I just have to go back to my original equation here and calculate what would y be when x equals negative 2. So y would equal negative 2 times x squared, so negative 2 times negative 2 squared, minus 8 times x, 8 times negative 2, and then plus the 3. Okay, so here we really have negative 2 times 4, and here we have plus 16 plus 3. Well, negative 2 times 4 is negative 8, plus 16 is positive 8, plus 3. Y turns out to be 11. So we are at the point negative 2, negative 11. So I'm going to be down here. Okay, that works, all right, is that we're going down there. Now, the next thing is, how does it curve? Does it curve up? Does it curve down? Things like that. That's what we're trying to figure out here. Well, one way that I see how it curves would be to see where does it cross the y-axis, and I talked about this before. It crosses this y-axis here where x is 0. So what we did here is when we plugged in what does y equal when x is negative 2, we're going to do the same thing, but say what does y equal when x is 0? And that's going to give us a powerful point here, because we're really just looking at a bunch of points. And what it equals is it's 3. So we just found out when x is 0, y is 3, and that's going to be on this equation or on this line too. So we have x is 0, y is positive 3. 1, 2, 3. All right. I think I made a mistake here in that I had a negative when I shouldn't have. Oh, and it's a positive 11. I know what I did. This is up here at positive 11. I apologize, guys. I don't know why I put it at negative 11, but it's at positive 11. So what I know now is that my line starts up here and it kind of curves down like this. The other thing I know is that it looks the same on either side of my axes. So I gotta move that over. So this point, I'm sorry. Sorry. All right, let's just get rid of it here. All right, so this point over here, it kind of curves down like this too. Gosh, my drawings kind of, they're sketches. Remember, we all do sketches. I had a clue that this was going to go upside down when I saw that negative out in front. When I see the negative out in front, that gives me a good hint that, hey, this is going to go upside down like a frown when we have that negative out in front. Same thing here. This one's going to go upside down as well because of the negative in front of the 2 out in front. So let's look at this one. Vertex form. If you remember in vertex form, I can just be able to look at vertex form and right away say what is the vertex. The vertex is always the opposite value here and the actual value here. So the vertex would be at -1, +3. That's always our vertex. Well, and then the axis of symmetry, remember how these always match, is going to be -1. These two always match. All right, so let's look at how we can look at equation here. How can we graph this? Well, what we know here so far is that my vertex is at -1, 1, 2, 3. Here's my vertex. That my axis of symmetry, I like to draw straight lines here, is along here. Another really helpful thing is to see how does this curve over. A good place to say how does it curve over is to find the y-intercept, which is what is y when x is 0. So again, I'm going to go back to my original equation, y equals -2, and this would be a 0 in here. All right, so I put in a 0 for my x. 0 plus the 1 is 1. 1 squared is still 1. So really we have -2 plus 3. Y would be a 1 when x is 0. So we have the point here now, 0, 1. And it's the same on the other side because it kind of curves in the same manner. And it really helps me to know how it curves. So I'm going to stop this video now, and there's going to be more videos that kind of go through more examples like this.